Well, and now we're going to see how to solve first order differential equations using dsolve. Dsolve, first of all, when you have a empty file name, when you press Ctrl U and a file name called untitled opens up. Now always save it in the working directory. Always you have to create a working directory first. How do you create a working directory? First, mtech matlab. We're going to choose mtech matlab, and now I'm going to choose Control S. The file is going to save in mtech matlab. So now let me give a file name as solving first order differential equation using dsolve. Okay, we're going to be using these methods. First of all, we are going to solve dy by dx is going to be is equals to x. Let's take a simple differential equation like this. Now how do you solve this particular thing is all you have to do is dsolve. Okay, and you are going to write your function or the differential equation, and then you are going to identify the independent, or let me write the function or the format as first ODE. It comes here. Okay, and in the second argument you are going to be having the independent variable. Okay, and the ODE for us is basically going to be written in the format of a string. This is getting converted to d of y will be is equals to x. This is our differential equation. This single d means dy by dx. Okay, so now what I'm going to write a dy in this particular place, and I know that my individual independent variable is x. I'm going to write x in this place. All I've done is finished, and I just have to run it. Go to the command line and see the result. It is solving for some time. Okay, answer is C2. Okay, what is the problem right now? That is because I've just written dy. So that means that it's going to be giving me a dummy answer is equals to x. I have not yet written my full differential equation. So now when I solve this particular thing, I'm going to get the solution as x squared by 2. What I'm going to do is I'm going to pretty the answer, pretty ans, which is always not required. So you're going to get it in a form like x squared by 2 plus this thing. And further, let's say that you have not specified your say what is your independent variable. I'm going to write a CLC here. I'm going to remove this. Let's see what happens. The solution for the differential equation where you have specified the independent variable, you get the x squared by 2 plus constant of integration. This is as expected as from your analytical or mathematical calculations of pen and paper. Now the second equation, we have not, in the second command I have not specified what is my independent variable. So I'm going to get tx plus constant of integration. Why is that happening? This happens because MATLAB always considers t as the independent variable. That is the default independent variable in MATLAB is t. Okay, that is the reason it has given you the answer as tx plus c. Okay, so now if I specify the independent variable as say something like c, then what I'm going to get, then let me evaluate this particular thing. I'm going to get cx plus constant. That's it. Okay, so now we have pretty much introduced you to solving a differential equation, the first order differential equation using MATLAB. Let me take another example. I have a function like dy by dx is going to be is equals to divided by y squared. On the top I'm going to have x squared minus 2x plus 3. This is my differential equation. I need to basically solve this. So this is, I know that the independent variable is x, so I specified my independent variable, but I have not yet specified what is my differential equation. So essentially the differential equation which I need is this, but it is not in the form that I am supposed to write. So this entire thing is going to become dy, and this is going to remain the same, and one will think there will be a star mark over multiplying into multiplication. Now what I do, I evaluate this particular selection, and I found that the answer is this much. Okay, let me evaluate this once again. Solve this. The answer is this much, and I can try to simplify this expression ans. I'm going to get, okay, no more simplification is possible, and if I prettify this answer ans let's see. Okay, this is our answer. Starhan, okay, really nice, a neat way of putting all the things together. That is one thing. Okay, next let's further see how do you solve this particular differential equation. When certain limits are provided to you, the domain the specified is varying from 0.5 to 5. That is my that is a domain which has been specified, and further the condition is y is equals to 2 at x is equals to 0.5. Okay, this is our condition. Let me simplify this right way of writing it. Okay, now these are the particular conditions that I have given. So now first you have to define the domain. Okay, now the domain has to be defined, and domain can be implicitly defined whenever you are plotting it. But of course, what about the initial conditions? Initial conditions are very important, and this is how the format goes: the D solve and your differential equations, followed by the initial conditions and followed by the independent variable. I know that the independent variable is x, and the equation that I am concerned about is this, right? Now what else do I have to do? I'll have to identify the initial conditions. Initial conditions once again needs to be written in the format of a string. So basically the initial condition states y at the value of x is equals to 0.5 is basically 2. Okay, this is our this is our format for the differential equation which has been provided. So now if I solve this, right click, evaluate selection. So now let's go. This is our solution for this particular thing. Now pretty answer. This is how the answer looks like, and it's nice. And why do we have the domain? Now we can make use of the domain to plot the solution. I'm going to use ezplot. Okay, ezplot. What is the answer that I have? Okay, let me say that the answer for this particular thing is this, and I'm going to evaluate this once again. Answer now if I CLC answer, oops, yes, this is your answer. And ezplot, I want to plot the answer within the domain of 0.5, or I can even define a domain as 0 0.5 and 5. This is my domain, and I'm going to just straight away write domain and evaluate selection, waiting for the graph. And as I have got the graph, this is the solution, graphical solution of the differential equation that we have. And this is all by using dsolve command. And what about by using the ODE23 commands? Okay, if I want to make use of the ODE23 commands, okay, that means solving first order differential, first order ODE using oh my god, happens to be smelling, using ODE23 command, ODE23 and ODE45. Okay, both are pretty much similar. I'm going to save this differential equation. I'm going to make this as a script file. Okay, why I'm going to make it as a script file, you will notice slightly. Now basically I have to define a function for the differential equation. Why do you have to define a function? That you will know it now. First, define your domain. Domain is 0.5. For always remember, ODE23 and ODE45 are numerical solver. They are not symbolic solver. Okay, so it's not going to give you the solution in terms of symbols or anything, but however it's going to give you a numerical solution in the terms of values of the dependent variable with respect to the value of the independent variable. Okay, so first I define the domain. I have the domain like this defined, and I can also define y at say x initial. It is I know that it is value of 2. Okay, that is done, and I basically need the solution for the differential equation. I'm going to write I'm going to call the differential equation solver. Okay, ODE23, and there are two arguments, one argument and the second argument, one argument, second argument. First argument, I'm going to basically define the function. I'm going to tell ODE23 where my function is defined. Where is the function defined? Okay, this is one thing. And further, what else do I have to do? I have to define the domain. I have to tell the domain. Okay, and it also has one more. It also has one more argument. One more argument is basically your initial condition. Okay, this is your initial condition. So how do we tell ODE23 that where is my function defined? So first of all, what is a function? A function is something in this place. It is something which defines the differential equation. Okay, where is the function containing the differential equation, or I can also tell what or which is that function which contains the differential equation. Okay, I think this is good. So I'm going to basically create a function, control new, create a function in the name, function, it has to have an output and a function name. Okay, function, okay, I can solve it, my ODE001 and certain inputs. And what are the inputs that I'm going to define it as? The independent variable and the dependent variable. Okay, and I'm going to end the function here. Basically the values for my the output is basically like this. You have a function like dy dy by dx is equals to x squared. Okay, I'm going to just copy it out from the other place. This is my differential equation which I need to solve right now using ODE23. I'm going to take it here and I'm going to put it there, control R. Okay, this is my differential equation. Basically I have to create this differential equation. Dy by dx will be my output, but only thing I cannot write it in that form though, and I can identify this capital D like this, so just to clear up the matters a bit. And the value of the dependent variable is y and the independent variable is x. I have defined this particular thing. I'm going to replace this by this one and control 3. This is my differential equation. This is the definition of the differential equation. I cannot have 2x there. This function has been defined. I'm going to go ahead and control save it, my ODE001, and go to this particular thing. Where is my party now? We have a question here, which is that function which contains the differential equation. Okay, the function which contains the differential equation is my ODE. So all you have to do is put that there, my ODE001. So it's going to give you some outputs, right? It's going to give you some outputs in the form of two variables, in the form of two arrays. Let me define as independent variable and the dependent variable. That is going to be this. Okay, now if I run this particular thing, let us see what happens. And has this finished running? Okay, let me close the previous figure and let me go to the command window. I think it has finished. If I give a value of input variable, independent variable, you see that it starts from 0.5 and it ends at 5. However, if I press the dv, it has to start with 2, right? It starts with 2, right, and it ends wherever the differential equation takes it. Okay, so now basically what we can do, we can make a plot of x comma plot of independent variable and dependent variable. We see we almost have the same kind of a fluctuation or the same kind of a figure. Let me put the two values on each other. Now I'm going to solve this particular thing, evaluate selection. Okay, now wonderful. What I'm going to do now is I'm going to go to the command line. I'm going to put hold on, okay, and plot in terms of r dot. Okay, I'm going to plot this. So if I go to the figure window, I have the values like this. Okay, so now these are the numerical and the analytical solutions. The continuous line represent the solution as obtained by the dsolve command, and the red dots which are actually represent the solutions which as obtained by using the ODE23 command. If I zoom on this particular place, let us see, is there any difference? Oh yes, there is a difference. This difference is basically primarily because of, I guess, the numerical error which I have got, and okay, which the ODE45 indicates, establishes. And I can also have this whole thing but to be done by using ODE45. Essentially it's a better, just it's a solver which contains okay, now I'm going to have plot Okay, we got a solution like this. It contains more number of values as well. That is it. I think this should complete the exercise on solving first order differential equations using using dsolve and ODE23 commands. Where is this?